Good evening everyone. Welcome to the video 7 on the homework portal. So this is regarding the solutions for the video number 7, homework number 7. Okay, so let me begin it. Let me share my screen. Yeah. Okay. So now that is moving across. Okay. Right. So the first question, so as you already know that this homework portal is it's a free video, and all the videos are free in fact, and you can subscribe to my channel and then you'll be able to view these videos. There's something like 5 MCQs are being given every day, and in the evening the solutions are being broadcasted. So today if I provide you the problems, tomorrow evening you will get the solutions. So you get one full day to work it out and get to know about the answers. Okay, so fine. So let us start with this. The first question reads, you show a digital meter over here, and what is there's a mirror behind it. What is the main purpose of the mirror? Now, as we all know, so we place a mirror. The reason is because if I look at it from this side or from the other side, okay, and I don't look at it in a normal way, that means perpendicular or on the needle, that means I will be able to see an image of the needle and as well as the needle itself. Two things I can see. So as a result of this, we need to put a mirror so that the image on the mirror and the needle coincides together, and thus you get only one image. And this minimizes or this reduces the parallax error, right? So therefore, so the right answer here is to reduce the risk of parallax error when reading the scale. Okay, let us move on to the next one. So first question was quite easier. An object is released from a stationary hot air balloon. Stationary hot air balloon. This is the ground, and it is released from a height at a height h. This is the height h here. Height h. And then an identical object is released from height h above the ground from another balloon that is rising at constant speed. You have one more, and now this is rising upwards. Okay, it's moving at a velocity v, constant speed. Air resistance is negligible. What does not increase? Right? Now let us look at this. The moment a particle is being thrown from here, then what will happen is it will gain the velocity. It will gain the velocity or speed of this particle, and as a result of it, the particle will go still a little bit upwards because gravity is constantly pulling. Then it will return back to the ground like this. This is what happens in the second object. Now, does this change? Distance through which it falls, does it change? Definitely, because this will fall immediately. This h will be the distance of the particle in the first case. In the second case, it won't be h, but instead, if I write this as some x over here, then it will go to a height of x, then return back by an x, another amount of x, and then will traverse a distance of h. There's a total distance traveled here would be h plus 2x for the second particle, and for the first particle, it will just be h. Definitely, distance through which it falls will change. So therefore, this is an incorrect answer. Time taken for it to reach the ground. Everyone can say time will be different because you see, so by the time this particle has been thrown out, it goes upwards and then it has to traverse another distance. This particle would have at least traveled until here. Okay, this particle would have traveled until here. And by the time this fellow comes over here, it would have already reached the ground. So who will reach faster? Okay, so this will reach faster over here. Time taken for it to reach the ground will definitely be different. Then the speed at which it reaches the ground, the speed, what factors of speed depends on? Speed depends on v square equal to u square plus 2as. That's what you can use. Okay, and s is displacement, a is nothing but g, u is nothing but initial velocity. When you are throwing this upwards, you have an initial velocity. When you drop it, the initial velocity is 0. Okay, so therefore it matters with the factor of u square. So definitely this is incorrect. This is also incorrect. Acceleration, of course, with 3 of the options are incorrect, the last option should be correct. That's what you can guess. But if I look at it, we want to prove it. Then we know when you throw the particle upwards or drop the particle downwards, or you throw the particle downwards, do whatever you see, the acceleration due to gravity will always remain the constant, right? Why? Because it is dependent on the earth. It does not depend upon the particle or mass of the particle. As a result of it, the only factor that does not increase, okay, whether an object is coming down or going up, whatever it is its acceleration. Okay, now let us move on to the next one. The diagram shows the forces acting on a block resting on an inclined plane. The angle theta is adjusted. Okay, now you have a plane. Initially you had a plane like this. You kept the object here. Then what did you do? You removed, you just lifted this plane like this. Lifted this plane like this. When you lifted it, it made an angle theta. You kept on lifting it until the object started sliding. Initially, why did it slide? Because there was a static frictional force. Now, which is true? Which is the maximum? What is the maximum coefficient of static friction between the block and plane? So the question is so simple. We have solved it several times in the class also. So what you need to do is W is given to you. This is theta, and now extend this line. Then what happens is this is 90 degrees, right? This is 90 degrees. Why 90? Because you see this normal force would be perpendicular to the plane. Thus, this is also 90 degrees. So as a result of it, this angle would be theta. If this angle is theta, then this side I can write this is W cos theta. And then this side, it will be W sin theta. And now what we need to write is, we need to write the equations of motion since it is not sliding. So we will write this as W, I'll write it here. And write W cos theta is equal to R and W sin theta is equal to F. And then what I will do is, we know that F is equal to mu times R, right? We know this also. Now W sin theta is equal to mu times R. Let me call this equation number 1. Let me call this equation number 2. Now when I do 2 divided by 1, what do I get here? I get sin theta by cos theta is equal to mu. Or mu should be equal to tan theta. We have already done this and I have called this as the angle of repose. Hope you remember this. Right. So answer is C. Very straightforward question. Nothing in this. The next one. A sun bather is supported in water by a floating sun bed. This is a question on vectors. Which diagram represents the magnitude of the forces acting on the sun bed? Which of them is correct? So towards it, if you look at it, see this line, this vector starts from here. Okay, which means it tells you about the total normal force given from the water surface. Now, what is this vector? This vector is nothing but the weight of the sun bed. Let me call this weight 1, W1. And what is this one here? The weight of the person, W1 and W2. If somebody is in equilibrium, then upward force should be equal to normal downward force, which means this length of this vector should be equal to sum of this length plus this length, right? Is it seen here? Definitely not, right? So if you add these two, the length of this line will not be equal to length of this line. See, if I try it, if you want, I can try it. This is my length of this line, the normal force. Okay, but while this one, okay, so it starts from here and maybe it extends until here, right? So what I can do is maybe I'll start from here, I'll extend until here. Okay, so this goes away. And this smaller one, where is it? It's hardly around half a centimeter. It can extend only so much. Now, as a result of it, you see, the total downward length vector is only so much, but this is much larger than this. So these two do not cancel each other. So definitely A is incorrect. Now apply the same logic here also. Now here you see this length is nearly equivalent to or more than this length. But what is the upward force? Upward vector is only so much. What is the downward force? This much. And you have to add this also. Extend this also. See, therefore, this length, downward vector length is much larger than the upper length. So it's of no use. So B is also incorrect. Now let us look at C. Now C, the same thing once again. Okay, only thing is the weight here is much larger. That's what I show. So definitely C is also incorrect by the same logic. Now, by chance, we know that it should be the right answer. But let us prove it also. See, this vector is this much big. This much big is this vector. And this vector is this small. And then you have this vector, which is this small. Now, sum of these two appears to be nearly equal. So therefore, D is the right option. Okay. So one has to logically reason this question. That's how do you get this? Right. Now, next one. A system that consists of a single spring. Okay, you have a single spring and you have a mass M, and as a result of it, its total energy is Ek. That's what is being given. Spring energy is Ep. Ep is given, and we know what is Ep. Ep is nothing but your half kx squared. Potential energy stored in the spring. Now what we do is, let us take two identical springs, and this is mass m over here. Okay, and just a moment. Now, when I say identical spring, both of them will have the same constant k. Both of them will have the same constant k. Now you see, let us say I put this object over here. As a result of it, the spring gets extended by a length x over here, right? Length x over here. What is the force acted here? mg over here. Okay. So thus I can now say mg is equal to minus kx. Currently, if I take the magnitude, only I can take mg equal to plus kx. I can do this. In other words, x is equal to mg divided by k. That's what we have. Now, if I look at these two springs, now these two springs are in such a way they are kept in parallel. Whenever two springs are kept in parallel, you would have learned this earlier also, that the total spring, the equivalence of these two springs is nothing but having a spring constant equal to 2k. What did I do? I just added these two springs. Okay. When two strings are connected in parallel, then the effective spring constant is 2 times the one of these springs. Okay. And if suppose if I had this as your k1 and this as your k2, then k effective would have been equal to k1 plus k2. Now, since k1 and k2 are equal, it becomes 2k over here. Okay. So therefore, now applying this logic, now see, the downward force is one and the same. Okay. By applying two springs over here, this load is not changed. The same spring, same load. So therefore, this becomes mg is equal to, now k has become 2k. 2k. That doesn't mean the force will increase, right? So the force has to compensate. So the springs will not come down so much. So in other words, now this becomes x by 2. If this becomes x by 2, then once again you see these two will go away. And as a result of this, okay, you get this kx once again, which is similar to this. In other words, what I said was that when you put two springs, when you put one spring, the extension is k. When you put two springs in parallel, the extension is seen to be x by 2. Okay. Now, based on this, let us find out what is the kinetic energy of the spring, the potential energy of the spring, which will now be equal to half into. Now, I have potential energy due to this, potential energy due to this. Okay. So, therefore, half k and the extension, what is the extension? It is not x. It should be x by 2 the whole square. X by 2 the whole square plus this for due to the first spring. Due to the second spring, it is half k into x by 2 the whole square, which should now be equal to half k into 2. Why 2? Because 2 terms, right? 2 into x square divided by 4. Now what I will do is, let me simplify this. I can now write this as half k x square divided by 2 once again. 2 ones are 2 twos are. That's what I've done. Okay. Which will now be equal to EP by 2. Right. So the answer is EP by 2. Okay. So you need to logically reason why is it so. Then only you will get the correct answer. Okay, friends. Thank you for watching this video until the end. And if you really like this, do share with all your friends and do subscribe it to our channel so that it will get further likes, and it's a good appreciation for me to continue doing similar kind of work. Thank you, one and all.